As I said in class during the review, I eliminated question 10, which is why you see it lined through here. And so our new question 10 was our old question 11, which was an implicit differentiation question. And to do this, we need to solve for y prime and consider y in any of these equations that have both variables to be a function of x. And even though it's not too obvious that that's what we're doing, we're actually differentiating any term that has y in it using the chain rule. Of course, here, since we have a product, we'll be using both the product rule and the chain rule. But to simplify, just remember that anytime you differentiate a term that has y in it, you differentiate it as you normally would and then tack a y prime onto the end of it. In this product, we see y as our first function, so we designate that as f, and so the derivative of that is f prime equals y prime. And the second factor function is e to the x. We designate that as g. So the derivative of g prime, is e to the x, since it is its own derivative. So we fill in our formula for the product rule, f prime g plus fg prime, with f prime, which is y prime, g, which is e to the x, plus f, which is y, times g prime, which is e to the x. Then we put that into our equation as the derivative of that product. Then we differentiate the x squared, which is very simple. It's just 2x. And then we differentiate the second, or the right side of the equation. So as I said, we differentiate it as we normally would, so we multiply the 2 around front times the 3, so that's 6y, and 2 minus 1 is 1, so that's 6y, but we tack that y prime onto the end of that, 6y, y prime. Then, the next thing we need to do is to isolate the terms that have a y prime in them on one side of the equation, and to do that, we subtract 6y, y prime, from both sides, and y times e to the x plus 2x from both sides of the equation. We now factor a y prime out of the left side, of the two terms on the left side of the equation, and so that leaves us e to the x minus 6y. So y prime times e to the x minus 6y is equal to negative 2x minus y times e to the x. And we then divide both sides of the equation by e to the x minus 6y. So that gives us this fraction, which is our y prime, negative 2x minus y times e to the x in the numerator, divided by e to the x minus 6y in the denominator. Now, if you get this far successfully, that is a perfectly good answer to this question. That is, in fact, y prime. But I have factored a negative 1 out of both the numerator and the denominator, which means I'm really just factoring out 1. And when I do that, this negative 1 comes out of both of these terms and they become positive. But the negative 1 comes out of the negative 6y, making it positive 6y. And there's no negative in front of the e to the x, and so that makes this term negative e to the x. And so negative e to the x plus 6y is the same thing as 6y minus e to the x. You may recall that at one point I said when you factor a negative 1 out of a subtraction, it just changes the direction of the subtraction. So this is a good answer, but if you want to do this to simplify even further, then we have 2x plus y times e to the x in the numerator and 6y minus e to the x in the denominator, and that is our y prime, or our dy dx, depending upon how you look at it. In addition to question 10, I eliminated the original question 12, which was an elasticity of demand, because that was not covered in this class, so that's why that is lined through here. And that changes this question, which I believe was our old question 13, to question 11. And from now to the end of the exam, the numbers are changed from what they were originally. So in number 11, we are given a demand function, demand as a function of quantity, and we want to find the average price over the demand interval for the interval from 20 to 30, which are quantities. And so average value is given by 1 over b minus a of the integral from a to b of some function. And so using that formula, which you can find on your formula sheet, differentiation and integration formula sheet, the upper limit is 30, so that goes here. The lower limit is 20 of the interval, and so that goes here. So this is 1 over 30 minus 20. It is outside the integral. Then we integrate from 20 to 30, the demand function, which is a price. Price is equal to this demand function, and so that's 1,000 over x here, dx, and then we can factor, so 30 minus 20 is 10, and we can factor the 1,000 out of the integral. So this is 1,000 over 10 times the integral from 20 to 30 of 1 over x, and 1,000 over 10 is 100, so this is 100 times the integral from 20 to 30 of 1 over x, and the antiderivative of 1 over x is natural log of x, so we will evaluate this natural log at 30 and subtract the natural log evaluated at 20, and that's inside these parentheses because that is the integral from 30 to 20, and we will multiply that times 100. Well, there is, as I think I mentioned during the review, there is a property of logarithms that says if you have two logarithms with the same base and you are evaluating the logarithm at one value minus that same logarithm at another value, you can express that as the logarithm with this base of the first value over the second value. So this natural log of 30 minus natural log of 20 becomes natural log of 30 over 20. Now, if you just simply put this expression, 100 times the natural log of 30 minus the natural log of 20, you would still come up with the same numerical value. But I have used that property to condense the logarithm. Of course, this simplifies as 3 over 2. And so putting this in my calculator and rounding, 100 times the natural log of 30 over 20, or natural log of 30 minus natural log of 20, is approximately 40.55. I think it was 40.5465 or something like that, but rounding to two places, we have 40.55, so that is the average price over the demand interval 20 to 30. Now in question 12, the new question 12, we are going to calculate the area bounded by the functions 2 times the square root of x and x. And I've identified the f as 2 times the square root of x because it lies above the other function on the interval that we're integrating over. And on the exam, I will actually give you the endpoints so that you don't have to solve for them. Without that information, you would have to set the two equal to one another and solve, and we would find that they intersect at 0 and at x equals 0 and at x equals 4. Since square root of x has no negative values in its domain, this function starts at 0, but the intersection forms the end point of the interval that we're evaluating on, and so what we're trying to determine is the area between them, which is this sort of shaded area right here. So This is the integral from 0 to 4, so here you see it, 0 to 4, of the f of x, which is 2 times the square root of x, minus the g of x, which is x, and that is expressed for the purpose of using the power rule of anti-differentiation as x, 2 times x to the 1/2. And now anti-differentiating, we add 1 to 1/2, that's then 3/2, and the reciprocal is 2/3, so we multiply that times the front here, 2/3 times 2x raised to the 3/2 minus the antiderivative of negative x. Well, x is raised to the first power, we add 1, and so that gives us 2, so this is x squared, and the reciprocal of x squared is, or I mean rather 2 is 1/2, so this becomes negative 1/2 x squared. This is 2/3 times 2x to the 3/2, which then is 4/3 times x to the 3/2, and we evaluate that at 4. So wherever we've got an x, we put a set of parentheses, and we substitute the 4 in, and 4 to the 3/2 is 32, because it's the square root of 4, which is 2, cubed, which is 8, times 4, which is 32. If you are not familiar with how that's done, if you don't understand what I'm saying, you can always just put this in your calculator as 4 raised to the 3/2. And if you have any question on how you do that with your calculator, you can text me or email me, and I'll give you the keystrokes for your particular calculator. So this fraction is 32 over 3. This one is 4 squared, which is 16, so 16 over 2. Then we evaluate this integral, or this antiderivative rather, at 0. Well, 0 to any power is 0, and times anything is 0, and over anything is then 0, and so here we have 0 squared, which is 0, over 2, which is 0. So this this evaluation is just simply 0. So we have 32/3 minus 16/2, and that simplifies to 8/3, which as a decimal would be 2.66, with the 6's repeating indefinitely, infinitely. And so either one of these answers, 8/3 or 2.66666, repeating, is an acceptable answer to this question.